Hi, I am Vijaykumar, Assistant Professor, Head of the Department of Physics, SNS College of Engineering. Today, I am discussing with my student in a case study of laser for using in optical fiber. We discuss in one experimental mode of case study. Right. So now we have discussed the case study on laser for using in optical fiber to finding some property of optical fiber. Right. So already we discussed in the laser and optical fiber topic. So this is a laser, right? The laser wavelength already marked in this device 660 nanometer, right? So 6,600 meter, that means it's in a form of Armstrong, right? It will be existed in the output of here. Then this cable is the optical fiber cable. So already I am telling that the laser is the tool. It will be communicated in one medium. That medium is the optical fiber, right? Then optical fiber property we discussed from today some parameter of numerical aperture and acceptance angles, right? So the laser, already you asked some question from the how it will be diverged from laser, right? So here the transmission of optical fiber, after the receiving part, the divergent we get the light. Okay, so the medium is very important, right? So the laser, it will be traveled from here, the same efficiency it will be existed from here, but it formed in a divergent beam. The divergent beam, it will be collected in a concentric circle of screen. The screen is in a movable form, right? The base is formed in the centimeter scale, right? When the light is gathered in the concentric circle, we have adjusted. Then we taken a distance between the source and the screen. Both we have taken the concentric circle. The concentric circle means it's a constant value of the circle. Right? It given from in a diameter, so you must be converted in a radius. Then other one is in the distance, right? So based on this two, we have calculated in a numerical aperture and the acceptance angle. The numerical aperture equal to r by root of r square plus g square, and the acceptance angle equal to the sine value of numerical aperture. So we have easily calculated from this data. Based on this, length is very important. This is normal experiment. How we have case study based on the experiments to the form of laser and fiber optics. You have change in the efficiency, it will be changed. One. We have change in the length of the optical fiber, it will be changed. Right? We have found in a meter or kilometer like that. Right? The output of the efficiency must be changed. So in acceptance angles and what is that? Numerical aperture, it will be changed. Another one category, the based on the material, okay, then based on mode, based on refractive index. That means the types of optical fiber, right? What types of optical fiber it will be used in the experiment, it will be changed in the output. So in the different types of optical fiber, you must be using the same laser source. We get in a different range of output from it. That is a case study we have also to be formed in our experiment. So that way I am telling that this is a case study based experiment of laser and fiber optics. If you have any doubt from this topic or this experiment, please ask me.
So can we calculate the value with the diagrams?
Yeah, because we formed this diagram based on certain angle wise. The angle must be start from here is 0, right? It forms some distance, right? So we have formed the center axis to the first order ring. It forms some, for an example, 15 degree or 20 degree, right? So we have calculated in other values. It's based on the diagram formations, right? Then any other?
So what type of semiconductor is used in the source?
Here we used in the PN junction diode lasers. That is you say it's a semiconductor, means it's a junction diode. The mostly we use in PN junction diode, the fabricating material of gallium arsenics, to addition of dopant in tellurium and germanium to the form of PN here. right? Then any other?
Sir, as you said, there was two types of optical fiber. One was plastic and another was glass. So which type of optical fiber is used here?
Here we have used in the plastics because it's an easily handled material, right? But accuracy wise, it's not a good to compare with glass because the glass we know that is a highly refractive index, but the plastic is in a, to compare with glass, it's in a lower refractive index because the made up of the material is a plastic or copolymers like that. Okay, so this is the plastic because it easily handled from the faculty and students' communities. Okay.
Today, sir has teached us about him. Today, sir has teached us about an experiment based on laser and optical fiber. The main motive of this experiment is to measure the numerical aperture and acceptance angle. The laser source has a wavelength about 660 nanometers, and the optical fiber is made up of plastic. Today, we have also learned that the numerical aperture and the acceptance angle changes with the wavelength of the laser source and the type of optical fiber and the distance of or length of the optical fiber. We can measure the numerical aperture and acceptance angle by measuring the distance between the screen and the light source and the diameter covered by the laser source in this screen.